Now that we've found the derivative of the exponential function e to the x, we should probably come back and try to figure out what the derivative of all the other exponential functions with different bases are. So remember, what we found originally was that the derivative of a to the x is a to the x times this crazy limit as h goes to 0 of a to the h minus 1 over h. And the problem is that we didn't know the value of this limit. Well, now that we know the derivative of e to the x, there's a different way that we can get at this derivative. So instead of using this formula, what we'll do is, to find the derivative of a to the x, we can rewrite this. We can rewrite this exponential function in terms of the base e. So this is e to the natural log a times x. And this is because a is equal to e to the natural log x. Right? This is just expressing the fact that, not natural log x, natural log a. This is just expressing the fact that the exponential function, the e to the something function, and the natural log function are inverse functions. So if you start with a, you do natural log, and then you do exponential, base e, they undo each other, and you just are left with what you started with, which is a. So I've just replaced this a here with e to the natural log a because they're equal. Cat mischief back there. But now we have some flexibility for how we can write things. So e to the natural log a times x, we can use the laws of exponents. This is e to the natural log a times x. And now we can take the derivative of this using the chain rule because we have an exponential base e with something inside of it. So the derivative is e to the same thing, natural log a times x. And then we have to multiply by the derivative of the stuff inside. And the derivative of natural log a times x, remember, natural log a is a constant. So this is a constant times x, and the derivative of that is just the constant, so natural log a. Of course, e to the natural log a times x, that's a to the x. Okay, so this is what we got for the derivative of a to the x. Notice this also tells us the value of this limit, right? This limit is the thing that is multiplying a to the x when you take the derivative, so it turns out that that's natural log a. This limit is actually natural log a, which is a little surprising. But this gives us a derivative rule for an exponential with any base, as long as the base is constant. So the base has to be constant for this to work. You just multiply by the natural log of the base. Of course, this works even for even when the base is e, because the natural log of e is 1. So that reproduces the derivative of e to the x, which we already knew. Just to have an example, let's take the derivative of this one. F of x equals 2 to the x. So f prime is, according to what we worked out up here, it's exactly the same exponential because the base is constant and the exponent is just the variable x, so it's the same exponential, but then we have to multiply by the natural log of the base.